Determine the estimated condenser load for an open-type compressor having a cooling capacity of 16,500 BTU per hour and a heat rejection factor of 1.32. So for the condenser load, if the heat rejection factor is to be considered, it is equivalent to the cooling capacity QR times the factor given. So our QR is actually 16,500 as in BTU per hour multiplied by the heat rejection factor 1.32. What is our condenser load, which is denoted as QR prime? It's equivalent to 21,780 BTU per hour. The locus or elevation to which water will rise in a piezometer tube is termed hydraulic gradient. Next one, a duct 0.40 meter high and 0.80 meter wide, suspended from the ceiling in a corridor, makes a right angle turn in the horizontal plane. The inner radius is 0.2 meters and the outer radius is 1 meter, measured from the same center. The velocity of air in the ducts is 10 meters per second. Compute the pressure drop in this elbow. Assuming the friction factor as 0.3, the density rho is 1.204 kilograms per cubic meter, and the length as 10 meters. So we are asked for the pressure drop. So we know that the pressure drop in a duct is equivalent to the specific weight of our fluid inside the duct times the head loss, which can be computed using the Darcy-Weber equation FLV squared over 2G. Okay, so we already have our density, meaning we could solve our specific weight. So let's use that. Our gamma is 1.204 kilogram per cubic meter. That's our gravitational acceleration, 9.81. And then this will be multiplied by our head loss using the Darcy-Weber equation. So F is 0.3, L is 10 meters, velocity is 10 meters per second, and that will be squared over 2 times our G, that's 9.81, times our diameter. Okay, so do we have a diameter here? As we can see, we don't have a diameter because our duct is not circular. It's actually rectangular given the height and the width. So in that case, we need to find the equivalent diameter. And the equivalent diameter of a rectangle that is equivalent to 2AB over A plus B, where A and B are the two dimensions of our rectangle. So using that formula, this is equivalent to 2 times then A be 0.40 and B as 0.80 all over A plus B. And that pressure drop is in Pascal. What is our pressure drop? The answer is 338.63 Pascal. And the best answer is 341 Pascal. 74. The heat per unit mass per degrees change in the temperature is called specific heat. 75. If the load on a water-cooled condenser is 150,000 BTU per hour, and the temperature rise of the water in the condenser is 10 Fahrenheit, what is the quantity of water circulated in gallons per minute? As you can see, there is a rise in the temperature, meaning inside the condenser, there is an involved sensible heat. Just a formula of mCp delta T. But as you can see, we are asked for the quantity of water in gallons per minute, meaning that is the volume flow rate. But we should all know that volume and mass are related through density, because mass is density times volume. That would be rho v Cp delta. That's another formula for sensible heat in terms of volume. Okay, so using Q as our load in the condenser, that's 150,000 BTU per hour. And since we are asked for the volume in gallons per minute, we should convert our load also per minute. So we know that 1 hour is 60 minutes. The density of our water, when the volume is in gallons, it is equivalent to 8.33 pounds per gallon. Hence volume, which is the unknown. CP of water using the English unit, that's 1 BTU per pound Rankine. And the rise in the temperature of the water is 10 Fahrenheit, which is also the change in Rankine. Pounds is also cancelled, as well as BTU. So the remaining unit for volume is gallons per minute. What is our answer? The answer is most nearly equal to 30 gallons per minute. 76. The heat transfer due to motion of matter caused by a change in density is called convection. 77. Determine the quantity of water lost by bleed up if the water flow rate over the tower is 30 gallons per minute and the range is 10 Fahrenheit. Percent bleed up required is 0.33%. So to find the quantity of water lost by bleed up, it is just the product of our flow rate, and that's 30 gallons per minute, and the percentage bleed up, which is 0.33%, or it is also 0.0033. What's our answer? This is 0.099 gallons per minute. 78. The temperature to which the air must be cooled at constant pressure to produce saturation is called dew point. 79. The load in a water-cooled condenser is 90,000 BTU per hour. If the quantity of water circulated through the condenser is 15 gallons per minute, determine the temperature rise of the water in the condenser. Okay, so for the heat involved when there is a rise in the temperature, that is the sensible heat, MCP delta T, or it's also the same with rho V CP delta T. If you are talking about volume of water, which is the case in this problem. Okay, so what is our Q, or the load? That is 90,000 BTU per hour. So we could convert that per minute. That will be 1 hour per 60 minutes. It's equivalent to the density of water is 8.33 pounds per gallon. That's our volume flow rate, and that is 15 gallons per minute. CP of water, 1 BTU per pound Rankine, and our unknown, delta T. What is our change in temperature, or the temperature rise? That is 12 times the change in Fahrenheit. 80. Weight per unit volume is termed as